Hey guys, today we're talking about solutions again, um, but this is part two. All right, so types of solutions and solubility rules. All right, when it comes to solutions, there are many different types. Two of the types we're going to focus on are electrolytes and non-electrolytes. Okay, electrolytes are ionic compounds that dissolve into ions in water and conduct an electric current. Okay, the more ions that something breaks into, the stronger the electric current is going to be. And part of the reason that it has electric currents because the metals are present. So when the ions get pulled apart, like in the video, the Edpuzzle you watched yesterday, it leaves behind the charged particles. So when electric currents go through the water, it's a it's able to continue going through the water because of the charged particles. All right. But when covalent compounds dissolve into water molecules, um, they dissolve into smaller molecules, but they're not actually pulled apart into individual ions, so they don't conduct electricity, right? There's no ions present, so there's no electrical current, which mean or another way to think about it, there's no metals because covalent compound is only nonmetals. So if there's no metals present, then there's not going to be an electric current. Okay. So here's a picture. I know it's kind of blurry, all right, but this is a non-electrolyte, okay? So like sugar dissolved in water, there's no individual ions. So when we try to send an electric current through the water, nothing happens, okay? Just if you had just plain regular H2O, um, like with no minerals or anything in it, it would not conduct electricity. But the reason that pools are dangerous is because you add salts and stuff to it. So when the salts dissolve in water, that's when you start getting these individual ions that do allow electricity to pass through them. And that's why pools are dangerous in storms because that attracts the lightning, the electricity and the lightning. Okay. Some things dissolve better than others. All right. That's why this is a bright light, and that's why this is not quite as bright as a light. Okay, because it has ions, just not all of it is broken apart. Okay, so, but if it conducts any electricity at all, it's an electrolyte. You might be thinking electrolyte sounds familiar. Well, it does, all right? Electrolytes are what's in Powerade and Gatorade. Okay, it helps keep the body hydrated because the salts attract water to hang on to the water. It's used to keep your pH balanced. It helps your muscles from cramping up. And it just keeps your nervous system sending signals to where it needs to go. That's why when athletes cramp, they're just like on the ground holding their leg because the muscles aren't doing what they're supposed to do because they've sweated out so many electrolytes that the muscles aren't getting the proper signals. And dehydration, just a combination of a bunch of different things. Okay. Um, but yeah, so that's when you hear them talking about the electrolytes or your sweat is more than just water. That's what they're talking about. Okay. The other types of solutions that we're going to talk about are unsaturated, saturated, and supersaturated solutions. We're going to start by looking at this illustration to kind of give you an example. Unsaturated is like when you're putting salt into water and it just keeps disappearing. Okay. Unsaturated means that it's not pool yet, so you can continue adding salt to the water. Okay. Saturated says no more solute will dissolve. So, like when you're adding the salt to the water, it's it's dissolved as much as it can, and now the salt's starting to collect on the bottom. Like it just won't dissolve anymore. So it's a full solution. It can't hold any more solid. All right. Again, saturated is full. That's the happy spot. Super saturated, it says crystals may grow. So if you've ever made rock candy, to make rock candy, you heat water up to where it's boiling, and you add as much sugar as you can to the boiling water, like a lot of sugar. And then you take the water off of the heat and you put like a stick or a string into the boiling pot. And as it starts cooling down, the sugar starts crystallizing onto the stick or onto the string. Um, that's a super saturated solution because that water is holding more sugar than it's supposed to as the temperature starts cooling down. So it starts forming crystals to the solid starts forming as crystals because the water can't contain it. All right, so now let's break it down into the definitions. Okay, so again, we talked about saturation or saturated solutions contains the maximum amount of dissolved solute for a given amount of solute at a specific temperature. No more will dissolve. All right, so that's this middle example here. They're not dissolving anymore, they're just gathering at the bottom. Okay, again, saturated is like the ideal amount. Unsaturated means that you haven't put enough of the solute yet, so it contains less dissolved solute for a given temperature than a saturated solution. More solute can still be dissolved. You can keep adding salt, you can keep adding sugar to it without it collecting. Okay, that's what this is showing. All right, it's dissolving before it's even to the bottom. And then the supersaturated that we talked about contains more dissolved solute than a saturated solution at the same temperature. So again, it's containing more than it should. So it'll form into a crystal if it's disturbed. All right, and I've got a YouTube video here that we're going to watch real quick that shows you what it's talking about.
Yeah, I don't know how. Go closer. Hold on.
Just start.
You can't even see it. Okay, go.
Hard to see.
Okay,
Right.
there's a crystal.
Right.
It might crystallize your. It's not going to crystallize on your phone.
Ready?
Yes.
So realize this has been sitting there all year long like this. Okay.
What is it? What is it?
Huh? Well, it's a water that has a huge amount of these crystals dissolved in it.
Oh.
It has so much of it that it's called supersaturated. Actually, it's holding more salt than water actually can.
How does that work?
Because I boiled it.
You dropped it in there?
What?
Oh snap! Oh my gosh, that's so cool! It looks like a football. What happened to the bug? What happened to it? It's still over there. That was just one frog. Look at it. It's oh, that was crazy. What's my nail? Oh my gosh. It does look like a beard. It's so cool.
Wait till it's all crystallized.
You would touch it either way. You can't do like that. He does not.
All right, so a little cheesy, I know, but you can see what happened. All right, so that's what I mean when I say like the whole thing can turn into a crystal. All right, now I've been talking about temperature, but I didn't get into a lot of detail, so this kind of helps show you what I was talking about. Okay, it's called the solubility curve. Any solution can be made saturated, unsaturated, or supersaturated by changing the temperature. So like looking at this graph, it says solute per 100 grams of water. So what this is saying is if you put salt or sugar into water, you're putting it into 100 grams of water. All right. And this is the temperature. Okay. So if you start with the temperature cool, then you can only put a little bit of salt in. All right. And as you start increasing the temperature, okay, as we start increasing the temperature, the you can start adding more salt or more sugar to the substance. Okay, this dot right here is saying that you put the perfect amount. Okay, first, I don't know if you can see the arrow or not. The dot in the middle of this is saying that you put the perfect amount of salt or sugar into the water. It can't dissolve anymore. All right. If we after that point, if we turn down the heat, then we're going to look at the dot on the left, the supersaturated dot, because when you turn down the heat and the water starts cooling back down, it still has all the salt or all the sugar dissolved into it. But it's really unstable because if you add another crystal, the whole thing could crystallize. That's this dot on the left. All right. So back to the middle dot, talking about saturated. Okay. From here, if I were to increase the temperature, okay, then I can continue adding salt. So if I keep it at the same amount that it was when it was saturated, then it's going to be unsaturated because as I increase the temperature, I can start adding more salt to it. All right. So that's what the solubility curve is. You might see something like this on the CBA, but that's what it's talking about. So you find the point on the graph. If it's above the line, it's supersaturated. If it's below the line, it's unsaturated. If the dot lands right on the line, then it's saturated. Okay, and again, anytime you see this 100 grams, that's just telling you how much water it's in, but the line is actually representing the salt and the sugar in the compound. All right, so here's some more vocabulary words. There's a lot of vocabulary in this unit. All right, if something is soluble, that means it can be dissolved in water. So like salt's dissolved in water, sugar is dissolved in water. In a chemical reaction, we're going to write AQ for aqueous solution, or meaning that something is dissolved in water. All right, so if you're looking at a chemical equation, you see AQ next to it, that means it's normally a solid compound that has been dissolved into water. Okay, it's not a liquid because a liquid means that it's just that compound that's melted, but this compound's dissolved into water. So that's why there's a difference between liquid and aqueous. All right, if something is insoluble, that means it will not dissolve in water. So that's the oil in water or like candle wax in water. That's what this picture is showing. Okay, candles don't dissolve in water. Right, so in a chemical reaction, you would put an S next to the candle wax to show that it's a solid and that it has not dissolved into water. All right, so how do we know if something's soluble or insoluble? Just by looking at a chemical reaction. All right, that's what this next part is going to be. So give me just a moment. And hold on just a second, guys. New share. There we go. All right, so this is what your notes look like right now. This is the solubility of common ionic compounds in water. Okay, so what this list is telling us is saying that if we're looking at just a chemical compound, okay, mostly ionic compounds, we can look at this and we can tell by using these rules if it's soluble, so like if it dissolves in water, or if it's insoluble, okay, meaning it does not dissolve in water. All right, so you have the soluble rules on top and the insoluble rules on bottom. And then it says the common exceptions to the right for each list. If it's a common exception, that means that it is insoluble. If it's a common exception on the bottom list, that means it's soluble. So it's the opposite of whatever list that it is. All right. So let's look at these examples and see if this kind of helps you out. If this is hard to read, this is also in your star chart. Okay, remember the polyatomic ion list that we used? this is right next to it on the star chart. Okay, so I'll be using this because it's a little bit clearer to read. All right, so the first compound that we have is PbCl2. So what you're going to do is you're going to look for the second part of the compound and you're going to find it on this list on the side. Okay, so we're looking for Cl and I found Cl right here. So chlorine is normally soluble, but I need to check my exceptions. It says chlorine is soluble unless it's with Ag, Pb, or Hg. Okay. Well, this is Pb right here, right? Okay, so that means that it's on the exceptions list. All right, so we're looking at chlorine and we're dealing with lead. So that means that this is insoluble. Okay, if it's insoluble, then that means, okay, in your notes up here, that it would be solid or written as S like this. Sorry. Okay, so now let's try this one. Okay, we have chlorine again. So we already know where chlorine is on the list. All right, and it says unless it's with compounds of Ag, Pb, or Hg. Well, this is not one of those. So that means it is soluble. So I'm going to write soluble here. And then we're going to put aqueous or AQ in this column. All right. So again, we don't look at the first part. There's only one time when we look at the first part. We're not there yet. Okay, so I'm going to look up OH on my list. All right, and we see OH right here on the insoluble list. And it says that it's insoluble unless it's with compounds of NH4, the alkali metals, calcium, strontium, or barium. Okay, so where it says the alkali metals, remember that the alkali metals is the first column. On the periodic table. Okay, so we're dealing with aluminum. We know that aluminum's not NH4. We know that it's not calcium, not strontium, not barium, but we need to double check to make sure aluminum's not an alkali metal. So when I look at the periodic table, this is the alkali metals. Okay, it's just this first column only. And aluminum is not on this list. So therefore, there is no exception to this. So it is insoluble because that's the list that OH is in. All right, and if it's insoluble, it's a solid. Okay, so pretty much if you're writing insoluble, you're saying solid, right? And if you're saying soluble, you're saying aqueous for this column right here. All right, so next we have CaOH2 or calcium hydroxide. So we're still looking at hydroxide on the list. And when I look through the list, I see that calcium is an exception. Okay, so calcium is on this list, so that means that it is soluble. All right, and again, soluble means that it's aqueous. All right, and for our last example, we have NH4CO3. Okay, so we're going to ignore the first part, and we're going to look up CO3. All right, so we have CO3. Okay, and it says CO3 is insoluble unless it's with compounds of NH4, and it is with NH4. Okay, so It is with NH4, so that means it is soluble and it is aqueous. Okay, hopefully this helped you out a little bit to know the solubility rules chart. Sometimes it takes a little bit to actually understand it, and there are some practice problems with this on the assignment for today. So I'm gonna find a YouTube video that goes over these a little bit more. So if you're confused on this, you can watch the YouTube video to help you out. If you feel like you got this, then go ahead and do the whole assignment. Make sure you enter the answers into the knowledge check. And you guys have a great day.